So this problem is similar to the one that we did in class today, where we were finding the change in the angle, and hopefully like my little searchlight that I drew and my little man. And so I spied with my little eye the 4 feet per second, and so I knew that that was a rate, and that was the man walking along the straight path. So that happens to be my y variable, so that's dy dt. And then the searchlight is 20 feet from the path. Of course, the path being up here, right? So 20 feet would be this distance on the vertical. And I want to know the rate that the searchlight is rotating, so that's my angle, so change in angle, when the man is 15 feet from the point on the path closest to the searchlight. So I have to ask myself, well, where's the point along this path up here where it's closest to the searchlight? And of course that would be this. So the man is 15 feet from that spot. And even if you were confused a little bit by that sentence, if you tried to put the 15 here, hopefully it doesn't make sense because your hypotenuse has to be bigger than x, which was 20. So that really left me no place other than the one where I put it to put the 15. Okay, so now, of course, I can solve for the side z. You might have to work this all out, or maybe you know that that's actually a triple, and it is, but I'll set this here so that you can see it. That is in fact a squared, not some crazy scary number. And so it turns out that z is 25. Now, if I'm going to find d theta dt, I need to be using a trig function. So the question is, which one should I use? Well, remember, I'm going to need several pieces, perhaps 5. If I was using the Pythagorean theorem, for sure I'd need 5, and then the 6th one would be a variable. Now, the only other thing that I might know is, of course, this length where the man's getting farther away, that's actually changing. So I definitely don't know dz dt. But this length here, where the searchlight is located from the path, that's not changing. So I know dx dt. So I'd like to be using, since I know dx dt and dy dt, I'd like to be using a function that uses x's and y's. And of course, with respect to my angle, that would be my tangent value. So I'm going to set up tangent of theta equals y over x. And now I'm going to take the derivative of it because I need to have d theta in there. So my derivative is, oops, definitely not tangent, is secant squared, and then my d theta dt, and then I have to use my quotient rule. Pause. I'm going to write the quotient rule, you write the quotient rule, and then you turn me back on and see if you got it. So check your work, make sure you have it. And now remember, secant is nothing more than the reciprocal of cosine, so if I took the cosine of theta, I'd have 20 over 25, or 4/5. And so if I flip that, I have 5/4 squared. And then I'm going to start plugging in all the values with my x's and y's. So let's see, I knew x was 20, dy dt was 4, y was 15, dx dt we said was 0 over x squared, which is 20 squared. Okay, so pause, see if you can work that all out and get d theta dt by itself. So hopefully you got 16 over 125. Remember, this is theta, so that answer's in radians. If I want to convert it into degrees, remember I have to multiply by 180 over pi. So that'll change my answer into degrees per second as opposed to radians per second. All comes down to multiple choice if you have to get an equivalent answer. Otherwise, this first answer that you got would be perfectly acceptable. See you in the next video.